Assalamualaikum. Hi everyone. So welcome to another video for chapter 2 Thermochemistry. In this video, we're going to focus on subtopic 2.3, which is Hess's Law, and at the end of this lesson, you should be able to do two things. First, state Hess's Law and then apply Hess's Law to calculate enthalpy changes using Algebraic Method and also Energy Cycle Method. And I will be giving you one bonus method. So let's take a look. So Hess's Law. What is Hess's Law? So by definition, when we talk about Hess's Law, it says that when reactants are converted to products, the change in enthalpy is the same whether the reaction takes place in one step or in a series of steps. Okay, to make this easier, I show you in diagram. Okay, so let's say I give you a general equation. Okay, so this is the diagram that I give you on your notes. So what you can see here is we have two different reactions that has different steps, but it has the same target or the same product, which is we want to find Y. We want to produce Y. Okay. To produce Y is either I change the reactant from X directly to Y, or it goes into two steps reaction, which is from X to A and has its own energy, and then from A to Y and also has its own energy. So this is what it means by the Hess's Law. It says that when the reactants are converted to products, our product here is Y, the change in enthalpy is the same whether the reaction takes place in one step or series of steps. So the one step reaction from X to Y, the total enthalpy change is equal to the change from X to A and then A to Y. So this is what it means by Hess's Law. And if you look at my diagram here, I put two arrows here. So the red one is clockwise and the green one is anti-clockwise. Okay, so why does this arrow significant? Okay, so this is why I came up when trying to make my student understand on how to write down your Hess's Law and then to calculate. So the sum of the delta H clockwise will equal to the sum of delta H anti-clockwise, meaning your equation it does not need to be like this. We can also write it as this: delta H2 plus delta H3 equals to delta H1. Anything you do, you just look at the arrow closely. Which arrow? This arrow. So if you look here, delta H2 and delta H1, it's in the same direction, which is clockwise. And then delta H2 and delta H3 in the same direction, and delta H1 in a different direction. So you put the delta H with the same direction on one side and the delta H with different direction on the other side. Okay, so this is basically your Hess's Law. Now we're going to look on the methods to calculate our delta H. Okay, we're going to apply Hess's Law to calculate our delta H, and for that, three different methods that we're going to use is, the first one is Algebraic Method, the second one is Energy Cycle Method, and my bonus method is determining delta H naught reaction from delta H naught formation. So please take a closer look here. We have delta H naught, meaning standard enthalpy of reaction from standard enthalpy of formation. Okay, so before we start with the question, with the example question, I want you to take back the note which have all definitions of enthalpy, because you will need those definitions later in this video for us to write down the equations correspond to each enthalpy given. Okay, so ready? Now let's take a look at the question. So example calculation to find delta H. Okay, I show you one example, which one question, and how to solve the question by using 3 different methods. Okay, so now let's look at the question and the methods that we can use. So this is the example question. So octane C8H18 liquid burns in excess oxygen to give carbon dioxide and water. Calculate the delta H combustion of C8H18. Okay, delta H not combustion. So we want to find the standard enthalpy combustion of C8H18. So given the information here, you have delta H not F, meaning standard enthalpy of formation. Okay, for our octane, for carbon dioxide, and also H2O. So now, how does we use all the information here to find what is the enthalpy change, standard enthalpy change combustion of our octane? Now, the first method is algebraic method. Okay, so let's take a look on how to solve the question that I gave you previously with algebraic method. Okay, so this is our question just now. So it doesn't matter which method we use, method 1, 2 or 3, the first step of each method will always be the same. So what will be our first step? So the first step will be, so target equation. Whatever method we use, we must start with writing down the target equation. So how do we know what is our target equation? So look back at your question. So what does the question ask you to find? So if we look at our question over here, the question asks to find delta H combustion of octane. Okay, so look back at the definition of delta H naught combustion. Okay, the definition is energy released when 1 mole of substance or 1 mole of compound is burned completely in excess oxygen. Okay, so our compound over here is our octane. Okay, so the target equation that you should write down, it will be so write down the combustion of octane. So you must start with C8H18, and you need to make sure for chapter 2 you must write down the phase of each compound given. So by right, the question will give you what is the phase. So here our phase of the octane is liquid. So since it is combustion, so it will be burned in oxygen gas. So the product of combustion, so this is our hydrocarbon. So the product of combustion in excess oxygen will always be our carbon dioxide, CO2 gas, plus H2O, and H2O in terms of liquid. Okay, once you write down the equation like this, the next thing you need to do is make sure that your equation is balanced. So balancing equation like you always do. So let us balance this equation. So first we balance the carbon. So you will get 8 carbon dioxide over here, and then after that you will balance first the hydrogens. So we have 18 and here we have 2 hydrogens. So 9 H2O for us to get the 18 hydrogens. And then lastly, check on the oxygens. So on the left hand side we have 2 oxygen. On the right hand side you have 8 times 2 plus 9. Okay, we have 25 oxygens. Okay, to balance the oxygen, since over here we have O2, so you just put down as 25 over 2. Okay, so this is our target equation. And for the target equation, you need to make sure, since this is chapter 2 thermochemistry, our equation must be a thermochemical equation. Okay, why this is not called a thermochemical equation? Because there is no data about the enthalpy. So you need to write down at the end here delta H naught combustion, and this is the value that we need to find. Okay, so that will be our first step. Now, the second step is for us to write down all the thermochemical equation with known enthalpy value. So what does this mean? Here, this is the substance that we know what is the value of each enthalpy given here. So we are given the enthalpy, the standard enthalpy of formation. Okay, so we need to write down for each and every one of this, each of every components here, we need to write down the equation to show that the formation of the substance. So recall back the definition of delta H formation. Okay, delta H formation is heat change when 1 mole of compound or 1 mole of substance is formed from its element at their most stable state at standard condition of 25 degrees Celsius and 1 atm pressure. Okay, so with that definition in mind, let's write down the thermochemical equation for all the 3 terms given here. So step number 2, writing down the thermochemical equation of known enthalpy. So this is the known enthalpy. Okay, and the enthalpy given to us is delta H formation. So recall back, what is the definition of delta H formation? Okay, delta H formation is energy change when 1 mole of compound is formed from its element at their most stable state at standard condition of 25 degrees Celsius and 1 atm pressure. Okay, so how are we going to use the definition to write down the thermochemical equation for each and every one of this compound? So let's start with the first one. Okay, so the first one, I write this as 1. Okay, we have the formation of octane. So since 1 mole of substance form, so 1 mole of octane form. So you need to make sure that your octane C8H18 over here is 1 mole. Okay, and then liquid. 1 mole of compound form from its element. So what are the elements on octane? Carbon and hydrogen. So you write down carbon and then plus hydrogen. Okay, from its element at their most stable state. Okay, so what is the most stable state of carbon at 25 degrees Celsius and 1 atm pressure? To make it simpler, how do you see carbon in real life? Okay, in the condition that you can see right now at room temperature. So carbon exists as carbon atom solid, while hydrogen, it exists as H2 gas, a diatomic gas. Okay, and then you need to make sure that your equation is balanced. Okay, so you will have 8 carbon over here, and then you will have 9 hydrogen. And you will not stop until here because the equation that you need to write down is thermochemical equation. So at the end of the balance equation, so delta H not F, you make sure you write down exactly what's given to you, negative 250 kilojoule per mole. So that will be the first thermochemical equation. Now let's try for the second one. So same step. Okay, so since we have 3 components here, so you will have 3 thermochemical equation. Okay, still the same. It's delta H formation, so formation of 1 mole of carbon dioxide. Okay, carbon dioxide is gas from its element, which is carbon and oxygen at their most stable state. So carbon solid, oxygen O2 gas. And then make sure that it is balanced. So 1 carbon and 2 oxygen. So complete the thermochemical equation with the information on the enthalpy. So negative 394 kilojoule per mole. Okay, so the second one. So do the same step for the third one. Formation of water. Okay, so formation 1 mole of H2O. Make sure H2O is 1 mole. So liquid from its element hydrogen and oxygen. So hydrogen at room temperature is H2 gas, and also oxygen O2 gas. So for this one, please be very careful when balancing the equation. Why? Because you need to make sure that the H2O over here stays as 1 mole. Okay, so we have 2 H2 settle, 2 H2 on the left hand side, 1 oxygen. On the left hand side, we have 2 oxygen. So how are we going to solve this? By multiplying it with half. So 1 over 2 times 2, you have 1. Okay, complete your equation with the enthalpy. So negative 286 kilojoule per mole. Okay, that we settle with the step number 2. Once we finish with step number 2, then we can proceed with step number 3. So step number 3, rearrange, multiply, divide the equation. Which equation are we talking about? Okay, this equation 1, 2 and 3. Okay, you can either rearrange the equation. Rearrange here means you can reverse the equation, or you can multiply or divide the equation. Okay, and then for this part, step number 3, rearrange, multiply and divide. When you do that to our equation, so first, when we reverse the equation, so let's say I reverse equation this is just an example. I reverse the equation number 1. Okay, it becomes C8H18 to produce 9H2 plus 8 carbon. So what happened to the delta H? It will become positive. Okay, so this is the sign. Recall back the two things that we need to look on when talking about delta H. The two things are the sign and the magnitude. Okay, the first one is sign. When you reverse the equation, the signs of the delta H will change. That's the first one. The second one is the magnitude. Okay, so if let's say I divide equation 1 all here by 2, so I will get 4 carbon and then 9 over 2 hydrogens and then 1 over 2 C8H18. So what will happen to my delta HF here? The value will also be divided by 2, but the sign did not change. The sign will only change if you reverse the equation. But for this one, when I half all the equations. So the delta H 250 over 2. So that's what you need to do. Okay, now what exactly we need to do? Okay, how do we know that we need to rearrange, multiply, divide, or just maintain the equation as it is? Okay, so what we need to do is look back at our target equation. Okay, the rearrangement, multiplying and dividing all of this equation, we need to make sure that we get back our balance equation, our target equation. Okay, so this is some tips on how you're going to do it. So check one by one of our components here, and then look on what equation does it appear. Okay, what do I mean by this? So let's say we want to look on C8H18, okay, our octet. So C8H18 is in equation number 1. So you need to make sure that the position is the same. So on our target equation, okay, the position of octane is on the reactant side, the left hand side. But on equation 1, the position of octane is on the product on the right hand side. So and then look on how many moles do we need. So we only need 1 mole, so we have 1 mole here. We also have 1 mole here. So what you need to do, okay, to get octane on the left hand side, okay, you will write down over here, we're going to reverse equation 1. Okay, so once you reverse the equation 1, so straight away write down the equation. So right now the equation will be C8H18 liquid to produce 8 carbon plus 9 H2, and like I mentioned before, since I reversed the equation and the magnitude is still the same, so I need to change the delta H. So right now I put down delta H as delta H1. So positive 250, and the unit will only be kilojoule. Okay, not kilojoule per mole anymore. The kilojoule per mole later on the final answer. But for step 3, it will be kilojoule only. So we have settled with C8H18. Okay, next is oxygen. So once you have finished with equation number 1, okay, so put a tick over here, meaning the next equation that we're going to focus is either equation 2 or equation 3. So if we have 3 equations here, on step 3, you will also have only 3 equations, not more, not less. Okay, now, so the next thing is oxygen. So if you look at the oxygen, the equation that we haven't used is equation 2 and equation 3. Both equation has oxygen. Okay, so leave oxygen first. So move on to the next one. Okay, so the next substance or the next species is carbon dioxide. Okay, so take a look on the target equation. Carbon dioxide is on the right hand side, okay, on the product, and the magnitude we need to have 8 moles of carbon dioxide. Okay, so look at equation 2 and equation 3. Which equation have carbon dioxide? Okay, our equation 2 over here. Okay, so for equation 2, we have carbon dioxide at the product at the right hand side, same as the position of the target equation, meaning we don't have to reverse the equation. Okay, but we need 8 moles. On our thermochemical equation over here, we only have 1 mole. So what you need to do, okay, so for equation 2, we will time everything by 8, meaning the whole thing over here, you will time it by 8. Okay, so write down back the complete equation. So since we did not change anything about the position, okay, just the magnitude. So now we will have 8 carbon plus 8 oxygen, make sure with all the phases, and then 8 carbon dioxide gas, and we put as delta H2. So the value over here, negative 394, is for 1 mole. So right now we have 8 moles. So 8 times negative 394. Okay, which is, you can straight away calculate the value. Okay, so 8 times negative 394. Okay, so I just put the real value over here. Make sure you put the value with sign. So if it's positive like this, put positive. So if it's negative, meaning it's an exothermic reaction, put as negative 3152 kilojoule. Okay, once we finish with equation number 2, okay, so put a tick on carbon dioxide. Now, the next one, we're going to look on H2O. So our H2O, we have it on equation 3. Okay, and we need our H2O on the right hand side. It's already in the right hand side, but the magnitude is different. We want 9 moles. The one given to us is 1 mole. So what you're going to do, you will times everything here by 9. So you put equation 3 times 9. Okay, and then write down the equation back. Okay, so you will have 9H2. Sorry. Okay, so 9H2 gas plus 9/2 oxygen gas to produce 9H2O according to what we have on our target equation over here. And then the delta H, so put as delta H3, so straight away times the value over here by 9, and we will get the value as negative 2574 kilojoule. Okay, so with that, we have finished step number 3. Okay, now, so step number 4 is combine and rearrange the equation. Okay, before I forget, if you look here, we did not do anything for the oxygen, but we have finished using all our 3 equations. So what does it mean here? The oxygen will be combined from all the 3 equations, okay, where we have oxygen. Okay, so for step 4, combine and rearrange equation. To get what? We need to combine these 3 equations that we have changed on step 3 to get back our target equation. So you must get back your target equation. Okay, so that's why I put one red line over here to show that I'm adding these 3 equations. Okay, so what you need to do over here right now is try to cancel out the equation or the compound that is the same on the left hand side and the right hand side. So what do I mean by that? Okay, so C8H18. So do you have anything here on the right hand side? So if there's no the same thing on the right hand side, so write it down back. So C8H18. Okay, and then carbon. So the carbon over here on the right hand side, and I have it also carbon on the left hand side. So you need to make sure when you want to cancel out the same term, it must be the same number, the same magnitude. Okay, so carbon, carbon. Okay, next, before we write down everything down here, double check. Okay, do you have anything else you can cross? So H2 and H2. So cross out the H2s. Okay, and then after that, oxygen. Okay, so the oxygen over here, 1 from equation 2 is on the left hand side, and from equation 3 it's also on the left hand side. So since it's on the same side, we will not cancel them out. What we're going to do is we're going to add them together. So if the compound is on different side, we will cancel it, but if it's on the same side, we will add the numbers. So 8 plus 9 over 2, okay, here you will get 25 over 2 oxygen. See, we already settled the oxygen problem. Okay, so since there is no more substance or compound that we can cancel or add together, okay, so complete our equation. So these are all the compounds on the left hand side, C8H10, oxygen, okay, and then on the right hand side, 8 carbon dioxide gas plus 9 H2O gas. So if you did the correct step on step 3, you will get the same equation on step 4 as the one on your target equation. So for here, we will have our delta H combustion. Okay, delta H not combustion. How do we get the numbers? So it will be delta H, simply just delta H1 plus delta H2 plus delta H3. Provided you need to make sure that when you are doing step 3, you already change all the numbers accordingly to what you did on this part. Okay, so now let's move on with step number 5. So the final step number 5, calculate the delta H. So like I mentioned before, to calculate delta H, so write down back the delta H naught. C is delta H1 plus delta H2 plus delta H3. We are adding these 3 delta H. So substitute the values over there that we already put down here. So it will be positive 250 plus negative 3152 plus negative 2574. Okay, and remember, the final answer, we want to find delta H not carbon. Okay, so make sure that you write down this correctly. Okay, it's subscript, and then you will get the answer as negative 5476. So at this part, at this moment, our energy, our delta H is no longer kilojoule. So it will be kilojoule per mole. It must be kilojoule per mole. If you just leave it as kilojoule, it is wrong. Okay, so this is our final answer. Okay, so on the same question, we will try the second method, which is the energy cycle method. Okay, for energy cycle method, the first step is the same as the first method, as the algebraic method. Okay, in fact, like I mentioned before, the first step for all the methods are the same, which we need to find what is the target equation. So since we are using the same question, the target equation will still be the same. Okay, so let's write down the target equation first. So here, this is the same target equation, octane plus 25 over 2 oxygen to produce 8 carbon dioxide and 9 H2O, and we want to find the standard enthalpy combustion of octane. Okay, so this will be our first step, the target equation. Next, the second step. So the second step is to construct the energy cycle diagram. Okay, so how are we going to construct this energy cycle diagram? Okay, for us to construct the energy cycle diagram, you need first to have the thermochemical equation for all the compounds that's given here. Okay, for all the species over here. So that's why these are the ones that we did from the first step. Okay, so to start the energy cycle diagram, what you need to do is you need to write back the target equation. Okay, so let me just copy this target equation. Okay, so let's put the target equation over here. Okay, and you don't have to put the delta HC here, but what you need to do is you will put the delta HC on the arrow. Okay, what do I mean by that? It's like this. Okay, so put here delta HC naught. Okay, the one that we want to find. Okay, so how are we going to start with the energy cycle method? So after you have your target equation written down over here, okay, the next thing is look at each and every one of the species inside the equation. Okay, so first let's say I want to do this one, C8H18. Okay, and then look for the equation that has your octane. So it's equation number 1. So to complete the equation, it will be carbon plus hydrogen. So we need to link all the information here inside a cycle. So we need to construct it to be a cycle. So this one is, I can say it's a bit tricky, so you need to try and error. Okay, but if you have all the equation here correct, so by all means you can get the correct equation inside here. Okay, so now since it needs carbon and hydrogen, so you don't see any carbon and hydrogen over here, okay, maybe you can skip octane first, but and then do others. Okay, so let's say carbon dioxide. So this is the equation for carbon dioxide. So it's from carbon to produce plus oxygen to produce carbon dioxide. So what you can do is you look here for equation for carbon dioxide is equation 2. Okay, so how many carbon dioxide do we need? We need 8 carbon dioxide. The ones that we have here is only 1 carbon dioxide. So times everything here by 8. So here, write down the equation like this. So you will put 8 carbon and then put the arrow. Okay, so okay, let me do it down here. Okay, 8 carbon solid and then plus oxygen. So the plus oxygen, put it here. Okay, plus oxygen gas. So this will be the first equation. Okay, and then you can label this as delta H. So in my example, the one that I gave you, I label it as delta H2. Okay, so delta H2, since the arrow is from carbon to carbon dioxide, the only different thing that I made here is I time it by 8. So 394 times 8, so you will get it as negative 3152, and make sure you have the unit. Just put the unit as kilojoule. Okay, so settle for the first one. Now the next one. Okay, we have since we don't want to do octane first, okay, let's proceed with H2O.
So which equation has H2O, the third equation? Okay, where hydrogen plus oxygen to produce H2O. Okay, how many H2Os do we need? We need 9. The one that we have in equation 3 is only 1. So, times everything here by 9. Okay, so draw your arrow. Okay, after drawing the arrow, so since the arrow is towards H2O, so our reactant is H2 plus O2. Okay, now to write down hydrogen, so you need to make sure that hydrogen is on the same line as carbon over here. Okay, so it will be, since we times it by 9, so 9 H2 gas, okay, plus 9 over 2 O2, and make sure that the oxygen is not on the same line. Okay, but as we look at the equation, it looks like one complete equation. What do I mean by this? So carbon plus 8 oxygen to produce 8 carbon dioxide, 9 hydrogen plus 9 over 2 oxygen to produce 9 H2O. Okay, and then so let us put it as delta H3, okay, and then times negative 286 with 9. So you will get the value that you will write down inside this cycle is negative 2574 kilojoule only. Make sure you just put only kilojoule. Okay, now after finishing the equation over here, okay, so the ones left the one that we haven't done yet is only our octane over here. Okay, so the equation for octane is this one. Okay, so 8 carbon plus 9 hydrogen to produce C8H18. Okay, so we already see here we have carbon and we have hydrogen. So you just need to put the plus sign over here. Okay, so 8 carbon plus 9 hydrogen to produce 1 mole of C8H18. Okay, for this one, for the arrow, you have 2 options. Okay, first, if you want to follow equation number 1 directly, okay, meaning it will be from carbon plus H2 to produce C8H18. Okay, so you can just draw your arrow, okay, like this. So once you draw the arrow like that, okay, since we haven't changed anything, we did not reverse the equation and we did not times the equation by anything, so you can just write down. So let me write delta H1 here equals to negative 250 kilojoule. Even though you did not do anything, okay, please do not put kilojoule per mole. So inside the cycle, the only unit you need to put is kilojoule. Okay, or if you want to do the arrow downwards, okay, so let's say I want to do the arrow downwards because I think, no, it's look prettier. Okay, so arrow downwards. Okay, so the sign over here will be 250. Can I do that? Yes, this is my cycle, this is your cycle. So you can do anything that is you to do the calculation. Okay, so this is our energy cycle diagram. Okay, So what you need to have in your energy cycle diagram, a cycle. Okay, so here, okay, let me move this a bit towards to the left hand side. Okay, so that way we'll have some space to do the calculation. Okay, so please remember back about the Hess's law that I mentioned earlier, okay, about the clockwise and anti-clockwise. Okay, what are we going to look now here is look at the arrow and look at the direction of the arrow. So identify which arrow follows clockwise and which arrow follow anti-clockwise. Okay, so let me use a bigger pen. So if you look here, the blue color one is the only arrow that proceed clockwise. Okay, only the blue color one. So once, so actually right now we are entering our step 3. Okay, step 3. What we're going to do is we're going to find what is the value of delta H. So let me just write down quick. So calculate delta H. Okay, calculating our delta H. So make it a bit prettier. Okay, just for you. So now, okay, going back here. So the one clockwise is only this one. Okay, only delta H, not C. So put that on one side. Okay, so I put delta H, not C. Sorry, C must be small. C, and the combustion is 4 octane. Okay, equals, since the only arrow follows clockwise. Okay, next, the other arrows over here. So if you look at the direction, all of it, okay, for delta H1, delta H2, and delta H3, it follows the same direction, which is anti-clockwise. Okay, let me change the color for you. So here, it follows anti-clockwise. So we're going to put all the delta H in the same direction on one side. Okay, so that's why the value of delta H1 will be plus delta H2 plus delta H3. Okay, so it will be like this. Okay, so what you need to do right now is just substitute all the value that you have. So let's say I have, so just substitute the value. So delta H1, I have 250. Okay, positive. Delta H2, negative 3152. Plus delta H3 is negative 2574. Okay, substitute all the value and then use your calculator to find the answer. So you will get the value as negative 5476 kilojoule, and for this one, the final answer you must put as per mole because we are calculating for delta HC9. Okay, so this is one step calculation. Okay, so this is what it meant by Hess's law. Regardless of how many steps of reaction, okay, the total enthalpy is the same. Okay, for one direction with the other direction, so the total enthalpy are the same, like this. Okay, now, so like I mentioned earlier, for this one, okay, if you don't want to put the arrow downwards, you want to stick with carbon plus hydrogen to produce C8H18. Okay, like I mentioned before, yes, you can do that. Okay, so let's say, let me just show you this. So after this, you can choose however you want to draw your cycle. Okay, So if the arrow is going upwards, meaning carbon plus hydrogen to produce C8H18, and before that I forget, here we have 25/2 oxygen. Where is the 25/2 oxygen? Here, 8 plus 9/2. We will get 25/2. Okay, so if the arrow is going upwards, okay, so the value of delta H1 here will be negative 250. So if I choose for the arrow to go upwards, what you can see here is the arrow will be different. Okay, what do I mean by that? So if you look here now, for clockwise, I have two arrows. I have this. Okay, two arrows going upwards, going on the clockwise direction, which is delta H1 and delta HC0. Okay, and then arrows that are going anti-clockwise, only this part. Okay, only delta H2 and delta H3. Okay, will it give us a different answer? No, you will get the same answer. Okay, so let's do the calculation. So let me change it to another color. Okay, so let's say I use this orange color. This is just for an alternative for you guys. Okay, so this is the one that we did and the one that is the same on your notes. Okay, I just changed a bit the your energy cycle method. So your energy cycle diagram over here, where instead of the arrow going downwards, I put it upwards. Okay, so right now, still using the same law, Hesss Law. So I put it down here. I write it down here. So it will be for the clockwise, I have now delta H C0 plus delta H1 equals to the anti-clockwise. I have delta H2 and delta H3. So delta H2 plus delta H3. Okay, substitute everything. So delta H0C plus delta H1 is negative 250 equals to delta H2 that we have calculated, negative 3152 plus delta H3, negative 2574. So if you look here, we still want to find delta H0C, delta H0C. So to find delta H0 for combustion, we need to move this negative 250 on the right hand side. So when you put it to the right hand side, the sign will change from negative to positive. So positive 250 plus negative 3152 plus negative 2574. Okay, so compare this one with the one that we did just now. It's the same. So that's why I said to you, you will get the same answer, which is negative 5476 kilojoule per mole. Okay, so it's up to you. Either you want to stick with the previous one that I did, which the same as your notes, or you can also do it like this. It's an alternative. Okay? Okay, so that will be for the energy cycle method.
The last and third method for the same question is determining delta H0 reaction from delta H formation. Okay, so how are we going to use this method? Let's take a look.
So first, to use this method, you need to make sure that you understand the equation that we're going to use is to find delta H reaction. So delta H0 reaction, any reaction, okay, combustion, neutralization, atomization, depends on what the question asks you. So delta H reaction is equal to the sum of all the delta H formations of our products, all the products, okay, and then minus the sum of the delta H not formation of our reactants for all the reactants. So this will be the equation that we're going to use. And to use this equation, okay, what information you must have? First, the question must ask you to find delta H naught, okay, meaning at standard condition. So the question asks for delta H naught combustion, and the information given, all the information given are delta H formation. So if let's say there is one information over here instead of delta H formation, the question gives delta H naught combustion of H2O is negative 286 kilojoule per mole. Okay, so can you use this method, the third method? No. It can only be used if all the informations given are delta H formation, delta H naught formation only. Okay, so since this question, we want delta H naught combustion and given to us the enthalpy of formation of all the substance over here, so we can use this equation. So for this one, like I mentioned before, whatever step it is, whatever method it is, the first step will always be writing down the target equation. So now let's write down the target equation first. Okay, we already have our target equation over here. Now let's use the equation. Okay, so to use this equation, first you need to make sure that you write down the correct enthalpy change that you want to find. So for this question, we want to find delta H naught combustion. Okay, so now let's take a look one by one. So I will use different color for reactants and products. So I will use red color for the product. So the sum of delta H formation of the product. So our product here is carbon dioxide and water. Okay, so for one carbon dioxide, the formation, the energy released to form 1 mole of carbon dioxide is negative 394. So since here you have 8 moles, okay, so what you need to do when you have 8 moles, you need to time the value that you have here by 8. Okay, so make a square bracket, okay, just to differentiate between the products and reactant. So 8 carbon dioxide, so 8 and the value is negative 394, so take the sign as well. And then the next reactant is H2O. So for H2O is negative 286 and we have 9 moles over here. Okay, so 9 negative 286. Okay, close the square bracket. So that will be for all the products. Okay, and then minus the sum of delta H reactants. So this is our reactant. So the one that I put in green color. So minus square bracket. Okay, the first one, 1 mole of octane C8H18. So this one. So put the value as negative 250. We don't have to times by any number because we only want one value. And then plus oxygen. Okay, now from the information given, there is no information at all for the formation of oxygen. Okay, why is that so? So you need to understand this oxygen over here is already formed. Okay, it's already formed at 25 degrees Celsius and 1 atm pressure, meaning at the normal room temperature, it's not formed, it's already exists. We don't have to make it, we don't have to form it. Okay, since oxygen already exists at room temperature, SO2. So that's why the standard enthalpy formation of oxygen will become 0. And this applied to any most stable state element. Element at their most stable state. So that's what I meant. Meaning, for let's say carbon. The delta H naught formation of carbon will also be 0. Delta H naught formation of sulfur is 0. Delta H naught of Cl2 gas at room temperature, chlorine is already a gas, so it is 0. So please make sure that you understand that. Next, once you have written down the equations like this, so the rest is simple. Just calculate by using your calculator. So you will get the answer as -5476, and you need to make sure that your answer is in kilojoule per mole. You will get the same answer regardless which method you apply.
So this will be the end of this video, where I give you 3 different methods to answer the same question. So on the next video, I will explain about the other 3 examples that I give you. So you can try to answer the 3 examples first and then compare with my answer. But if let's say you need extra guidance, so you can watch the video, the next video, on step by step how to solve all the questions. So that's all for now. Thank you.